Here we discuss the kinematics equation. We prove the first equation of motion by graphical method. Here we discuss the object initial and final velocity. When object at the rest and origin position, its initial velocity is v I. When it moves to the position B, its final velocity is v f. Here we draw the perpendicular from B to D and join the point A and C. So we can find the slope of from the v velocity time graph. Slope of the velocity time graph, that is equal to the acceleration that is can be found by the slope of velocity time graph. Here we can write that slope that is equal to BC, our AC vertical distance, our horizontal distance, that is the AC. BC can be found by total distance BD, that is equal to the VF, and CD, that is equal to VI. So BC is equal to BD minus CD, our AC. So here we can write that BD, that is the equal to the final velocity, and CD, that is equal to the initial velocity, and AC, that is equal to time t. So here we can write that AT is equal to VF minus VI, and VF is equal to VI plus AT. That is the first equation of motion. Now we prove the second equation of motion by graphical method. Here we can find the displacement in this graph, that the area of the rectangle plus area of the triangle, that is equal to the displacement area of rectangle plus area of triangle. Area of rectangle, that is the OACD, and area of triangle, that is the ABC. So here we can write rectangle area, that is the base multiplied by height. Here is the base is OD and height is CD, plus area of triangle, that can be found by formula half multiply base into height. Base, that is the AC, and height, that is the BC. So here we can write that as OD, that is equal to T, and CD, that is equal to VI plus half AC, that is equal to T multiplied by BC, that is find in the latest equation, that is equal to BC, that is equal to BD minus CD. So you can write it as VIT plus half T multiplied by VF minus VI. BD, that is equal to VF, and CD, that is equal to VI. So VIT plus half T, we know that acceleration, that is equal to change in velocity over time. So it is the change in velocity. So change in velocity is equal to A T. So put it here, VIT plus half T into A T, that is equal to VIT plus half AT square. That is the second equation of motion. Now we prove the third equation of motion. We know that is the can be find the displacement by this graph, that is the initial velocity plus final velocity over 2 into time t. So displacement, that is can be represented by as initial velocity here is VI, and final velocity is VF over 2, and time is t. Now from the first equation of motion, that VF is equal to VI plus AT, and T is equal to VF minus VI over A, put in this equation. So S is equal to VF plus VI our 2 and t is equal to Vf minus Vi. So our A can be write it as Vf का square minus Vi का square over 2A. So in final equation we can write it as 2as is equal to Vf का square minus Vi का square. So that is the third equation of motion.